of the flow measurement device. So basically, flow measurement devices are classified into two categories: quantity meters and flow meters. Quantity meters are again weight or volume tanks type and positive displacement. And again, flow meters are classified into further subcategories. So let us see the first category of the devices which are used for measuring the flow, that is quantity meters. So rotameter is one type of device that measures the flow rate of a liquid or gas in a closed tube. So we are all familiar with that. So this is one of the devices that is used to measure the flow in terms of quantity. So it measures the flow rate of any liquid or gas in a closed tube. So when fluid is flowing in a closed tube, of course on one side, or to measure the fluid like a gas cylinder which is tightly fitted, of course not exactly to gas cylinder and other pipelines. So in a closed tube, this can be used to measure the flow of the liquid or the gas. Similarly, so it belongs to a class of meters. Generally, rotameter is classified under a variable area type meter. So here the cross-sectional area of the tube is going to be, the device cross-sectional area is changing. So it contains, it may contain a glass tube whose cross-section is changing. Cross-sectional area is changing from one end to the other. That is why it is called as a variable area type of flow meter. Because when flow is increasing, the fluid may moving from the low cross-sectional area to the higher cross-sectional area end of the tube. So it belongs to a variable area type of flow meter. So this measures the flow rate by allowing the cross-sectional area of the fluid travels through and to vary, causing a measurable effect. So by changing the cross-sectional area of a fluid, so when the cross-sectional area of a tube where the device is used to measure the flow, accordingly the area of the fluid where it is flowing is also changing. The quantity is also going to be changing. So it belongs to the variable area type of meter. So it is used to calculate the quantity of the flow. And you can see the diagram here, the basic principle here we will discuss here. Especially the device is put it in the vertical plane. The rotameter is put it in the vertical plane, and maybe it is put it in a channel by breaking the fluid flow or by obstructing or at the end of the channel. The fluid will enter from one side of this channel you see here. Now this is a flange here. This is a tapered glass tube, and it is provided with some scale here or a metered calibrated scale. And this is a rotameter body. This can be a glass tube or again rotameters are also various categories: glass tube type and purged type or metal tube type. Now in this tapered glass tube, there is a flow. Just like you see a soda glass tube. So inside you have a glass ball. మనందరికి తెలుసు సోడా అంటే లోపల ఒక గాజు గోళీ ఉంటుంది. లోపల ఏముంటుంది? లిక్విడ్ విత్ సమ్ CO2 అండ్ అదర్ గ్యాసెస్. సోడా మనకి అందరికి సోడా తెలుసు. సో మనం ఆ పైన గ్లాస్ బాల్ని ఏదైతే గాజు గోళీ ఉందో దాన్ని గట్టిగా ప్రెస్ చేయగానే లోపల ఉన్న గ్యాస్ బయటకు వెళ్ళిపోతా ఉంటుంది. అప్పుడు పొజిషన్ ఆఫ్ ది గాజు గోళీ కూడా చేంజ్ అవుతుంది. So similarly, that is indirectly called as a flow. So here you have a float here having certain cross-sectional area and shape. So this float is changing its position from bottom to top because the cross-sectional area of this tapered tube is also changing from bottom to top. So when fluid is entering on one side of this, as shown here, flow in, then if the flow velocity or quantity is increasing because the cross-section area is changing from bottom to top, then this float is going to be moving to top. Suppose when the flow is reducing and there is When a flow is flowing full in a container, say, then this rate of flow is increasing more quantity, then this float may move upwards. Suppose when the flow is reduced, half filled container or a tube, because the flow rate is reducing, then the float will move down. Accordingly, the reading on the scale is also changing, how much quantity of the fluid is flowing. Now, the moment of this float is adjusted because of the buoyancy force or drag force and the gravitational force, because float is trying to move upward and the gravitational pull is downwards. So when these two are balanced, the float is settled at a particular position, because the float may not go on top and hit it. But when the upward force, that is drag force or float force due to the fluid movement, is balanced by the gravitational force downward, then the float will settle at a particular place. That is, this net gravitational force will causes this float to settle. So thus, this is a wonderful instrument for measuring the flow of a fluid or quantity. And this is very simple device and can be used by anyone. You don't need much skill and compatible, and even cost is also very less. We'll see this further. So from the exam point of view, you can use this diagram. We will provide the material, and the textbook provides this diagram. So this is the outlet fitting. So inlet flow, the flow is entering here. This is the tapered glass tube. The water or fluid is flowing from the outlet in this direction. And this is the metering float. The float is moving from this position to this position. So initial position, that is inlet float stop. And for the minimum flow rate, when the flow is less because of the cross-sectional area of the tube is less here, the float may move from here to here. And for maximum flow, because the cross-sectional area of the tube flow channel is increased here, more quantity of the fluid will enter here, the float will move from here to here. So three positions. For the inlet position, the float is here. For the minimum amount of the quantity of the fluid flow, the float is here. For the maximum flow, due to maximum annular area here, more area is here at the top, the float may move here. So three positions are shown here. So this is basically the rotameter working principle. So this is coming under variable area type of flow meter. It is put it always in the vertical position. Fluid will enter in one direction and leave at the other direction. So this is the most extensively used form of variable area flow meter. So it consists of a vertical tapered tube, already we have seen, and a float which is free to move up or down within the tube as shown. The tube is made tapered so that there is a linear relationship between the flow rate and the position, because when the flow is increasing, with the increased flow, the position of the tube is also, float is also changed. The free area between the float and the inside wall of the tube forms an annular space. Some space is empty based on the quantity of the fluid. The tube is mounted vertically with the small end of at the bottom. The fluid to be measured enters in the tube bottom and passes upward around the float and exit at the top. So when there is no flow through the rotameter, the float rests at the bottom of the tube, as seen already, three positions. And here, the maximum diameter of the float is approximately the same as the bore of the tube. When the float is at the bottom, so maximum diameter is the same as the bore of the tube, that is inside diameter. So when the fluid enters the tube, the float moves up and the flow area of the annular orifice also increases. The pressure differential across the annular orifice is paranormal to the square of its flow area, because the cross-sectional area is indicating the measurement of the flow. That is a square of the flow rate. The float is pushed upward until the drag force produced by the pressure differential across its upper and lower surface, because there is a change in the cross-sectional area at the top and the bottom. So the weight of the fluid, if the flow rate rises, Then the pressure differential and hence the lining force or the drag force increases temporarily, and the float then rises, widening the annular orifice until the force caused by the pressure differential is again equal to the weight of the boat. The float is also called as boat. Thus, the pressure differential remains constant, and the area of the annular orifice, that is the free area between float and inside wall of the tube to which the float moves. So, changing in proportion to the flow rate, any decrease in the flow rate causes the float to drop to lower position. So, every float position is corresponding to one particular flow rate. So, and the float is moving gradually from bottom to top. At each position, accordingly, the flow rate in terms of quantity is indicated in this scale. Every position of the float indicates a particular flow rate for a given density and viscosity. So as you've seen already, you have a calibrated scale. So it provides a direct modification of flow rate. The tube materials of a rotameter may be glass or metal. Already you have seen higher volumetric flow rate through a given area increases flow speed. Generally, the floats are made in different shapes, from spherical shape to ellipsoidal shapes. They are the common type shapes. So the float can be diagonally grooved, so it can be made some hollow inside, and partially colored so that it can be seen from the outside in the glass tube, because position of the float can be easily identified when it is colored, so that it rotates axially as the fluid passes. So the already you have seen the float is stuck since it will only rotate if it is free. Readings are usually taken at the top of the widest part of the float, the center for an ellipsoid, or the top for a cylindrical shape of the float. Some manufacturers use a different standards. So the float must not float in the fluid. It has to have a higher density than the fluid. Otherwise, it will float to the top even if there is no fluid. So it must not have higher density than the fluid. You are seeing such a diagram here. This is the float here and a calibrated scale. This is the tapered glass tube. On one end, the fluid enters, on the other end, fluid is leaving. So you can, based on the position of the float, you are able to measure the flow. The mechanical nature of the measuring principle provides flow measurement device. That is, it does not require any electrical power. If the tube is made of metal, the flat position is transferred to an external indicator by magnetic coupling. So this capability has considerably expanded to the range of applications for the variable area flow meter. Since the measurement can be observed remotely from the process or automatic control. And you are seeing a further clear diagram of a flow meter. Here you can see a metallic type of flow, the float or the boat, and a glass tube where there is a calibrated scale and calibrated for the velocity and quantity measurement. So that is how you can see based on the position and shape. Here you are seeing some tapered position of the boat, and here you can see a cylindrical type of boat or the float. Now let us finish this topic by its advantages and disadvantages. So a rotameter, simply called as rota, is require no external power or fuel. It uses only the inherent properties of the fluid, its density and viscosity, and along with the gravity to measure flow. So easy in reading and installation. So it is relatively a simple device that can be mass manufactured. So devices can be made in big volume, many quantities. So cheap materials allowing for its widespread use. The area of the flow passes increases as the float moves up the tube. The scale is approximately linear. So linear measurement of the scale or calibration will help in easy measurement of the flow. And a clear glass is used, which is highly resistant to thermal shock and chemical action. And the device is relatively less cost. And it is used to handle a variety of corrosive fluids also, and easily equipped with data transmission, indicating and recording devices. Even though it has so many advantages, still it has certain disadvantages. So due to the use of the gravity, because when the float is moving upward, gravity is used here. The rotameter must always be vertically oriented. Remember, it is to be put it in a vertical position, not in the horizontal position, and right way up with the fluid moving upward, and less accurate when compared to Venturi meters and other orifice meters. Due to its reliance on the ability of the fluid or gas to displace the float, graduations on a given rotameter will be only accurate for a given substance at a given temperature. So based on the substance also, rotameter is going to be changing. The main property of importance is the density of the fluid here, but sometimes viscosity also may be influencing the meter. The floats are ideally designed to be insensitive to viscosity. However, the float is also influencing certain fluid conditions. So separate rotameters for different densities and viscosity may be used on multiple scales of the same rotameter. Because of the direct flow indication here, resolution is relatively less compared to the other measurement principles. Readout may be uncertainty near the bottom of the scale. Oscillations of the float and parallax errors may also involve. So the float must be read through the flowing medium. Some fluids may be obscure the reading. Sometimes a transducer may be needed for electronically measuring the position of the float. And they are not easily adapted for reading by machine, along with a machine. So they are not generally manufactured in sizes greater than 6 inches per 150 mm. And sometimes the glass may be subjected to breakage after certain period of using, limited to small pipes and capacities, always mounted to be mounted in vertical position. So it may be subjected to oscillations. Thus, we have seen today the various types of the flow measurement and basic principles of flow measurement devices. And one of the familiarly used flow measurement device, a rotameter, which comes under quantity meters, we have discussed today. We'll discuss the other types of special meters, and that comes under the second category, exclusively flow meters, in the next class. And we'll let us see some visual related to this, how some animation by the YouTube video. You can also see that maybe maximum for 1 or 2 minutes here. Now see here, so this is a rotameter, a transparent glass tube, a float or a bob or a boat, it is called. This is transparent tube. So inlet flow is entering here. The fluid is entering through the exiting to the outlet here, you see. So there is a graduated scale as seen here. It is transparently visible. So the scale is calibrated here. So when the fluid is entering here, it is flowing and it is pushing the boat or the bob in the vertical upward direction because of changing the annular space that is between the boat and the tube here. Now see here how the boat is moving upward because of the annular space between the boat and the fluid and the glass tube. So when the flow quantity is more, or velocity or indirectly, more quantity of the fluid is entering, then the boat is moving upward. And after crossing the boat, the fluid will exit through the outlet or at the exit portion. Suppose when the quantity of the fluid is reducing, the volume of the fluid is reducing in a pipe or a pipe channel, if there is less quantity of the fluid like this, and the fluid is moving slowly, gradually like this. So that the quantity is less and the velocity is less. So therefore, the bob or the float is moving downward. Accordingly, you can see the meter reading in the graduated scale. Now the float position is balanced because of the drag force or the buoyancy force and the gravitational force. The net force, that is, suppose if the drag force is more, gravitational force is less, the boat will move upward. If the drag force is um, less and if the gravitational force is more, boat will move down, and drag force is more, then the boat will move upward. Let us discuss the remaining types of the instruments in the next class. So thank you, Anand.